Hi guys, let's get started with a new series which is based on quantitative finance, and it's nothing new as such in the world of quants. But yeah, let's start to get the basics right. So we're going to cover a couple of topics in this one, like stationarity, what is auto regression, what is the auto correlation or serial correlation in a regression or in a time series data, what are the moving averages, and finally we'll cover the model which is a combination of all these, which is the ARIMA and the SARIMA models, right? So let's get started. So what is stationarity? A stationarity basically means that a time series is it needs to be very consistent in terms of its pattern, right? Let's take an example in the Excel that we have created. I've taken the yearly, say suppose sales data, right, from 2001 to 2022, and this is some random sales data, and I try to plot a graph out of this one. So it is very steep, right? What it looks like that the data is like this, and it is dependent on the time series. It is dependent on the time series. So as and when the time is increasing, we see that the trend is going upwards. So the data is not stationary, right? The data is not stationary because it is dependent on time. But a stationary time series data has to be independent of time. So how do we achieve this? We achieve this by a method called as a first differencing method. First differencing method. So we take this data and we try to create another series, which is basically the difference of current data point minus the previous data point, current data point minus the previous data point. So this way we have differenced the current value with the lagged value, and now we try to plot this into a chart. We have done this on this page. Though this is looking steep, but in reality it is quite flat, because you can see the date range is from 150 to 218 over here, and the original data range was from minus 1800 to 2000 positive, right? So that's almost a 4000 units of data point, and over here we have a 78 units of data point from 4000 to 78. Now when I plot this in a proper Excel, this will look more like this, right? It will have some kind of steepness. It will not be steep like this, it will be like this, right? So much more relevant data, this one, because this is not showing any trend. It is not showing any trend. The distance from the mean, whatever will be the mean value, is close to its value. The distance at or the mean at multiple levels is close to the mean, but over here you can see the distance or the mean is increasing as and when the time is increasing. That means it is not stationary. It is not stationary, it is ever changing. It is ever changing and unpredictable. Ever changing and unpredictable. So the first thing in time series data is that the data has to be stationary, and a time series data is to be considered to be stationary if the mean and variance across the time series is consistent, not constant. Is consistent means it could be in the range, it could be in the range but not constant, or has nearby values, which means it can be close to some that mean value, but not exactly, but close to that mean value, and is independent of time. So if all these criteria are okay, the time series is said to be a stationary time series. So any data that we get, this could be forecasting data, that could be rainfall data, it could be sales data, anything. We have to first see whether the data is stationary or not. The next part is the auto regression. So we all know what is regression, right? We have studied that in our school, and a very famous equation, y is equal to mx plus c, which was used to plot the slope of the line, right? Where c is the constant or the error term, and this is the slope. So this is called linear regression. But what is auto regression, right? We need to understand what is auto regression. We know the word regression. We now need to find what is auto regression. It means that a dependent value is derived from the previous lagged values. So if I want to predict what is my, say, rainfall output for the month of October, it is dependent on how much rainfall it has happened in the month of September, or how much rainfall has happened in the month of August, right? YT stands for the future, which is October. T minus 1 is September. T minus 2 is August. So if the time series data is dependent on the data lagging behind, the, then this regression is known as auto regression. Auto regression. That means regression with its own lagged values, regression against its own lagged values. So this is auto regression. Auto regression assumes that there is a linear relationship between future value, past value, which could be one period or it could be two period. This is called the auto correlation or serial correlation, that is having a correlation with its past two values. Now what is auto correlation, right? It is a correlation of a given time series and a lagged version of itself over successive time intervals. And as you know that all correlation ranges between -1 to +1. So what it is actually saying is, in real sense, that if I plot a data and I have this value, say of August, I have this value of say September and this value of October, the correlation between output of September with August is known as the autocorrelation. So if the autocorrelation between current value and previous value is very close to 1, that means that the data is very much dependent on its previous value. So if the data is too much dependent on its previous value, we'll have a very high autocorrelation, right? Now here I have put a line that everything depends on what confidence level you are regressing the data. So I've given a chart over here. So let's try to create this chart in reality. Just give me this time. Yeah. So what I'll do is I'll try to create this chart in this way so you can understand. We all know this is the normal distribution, and say I'm doing at 95% confidence level. So this will be minus 2.5, right? And this will, sorry. So we all know that if I plot this normal distribution at 95% confidence level, I'll have 2.5 over here and 2.5 over here, negative 2.5 and positive 2.5. Now the bars that you see in this chart is basically the autocorrelation of its lagged value. So if say I had this up till t minus n, up till n period, or say for simplicity I'll say t minus 8, up till 8 previous period I am taking this data. So I'll have a correlation of 8 with 7, 7 with 6, 6 with 5, 5 with 4, 1 with 2. Similarly, so I'll get a graph, right? I'll get a graph of autocorrelation. What is the correlation of each period? 1, 2, 3, 4, right? Similarly, in this way, for each of the value, I'll get an autocorrelation. The and the entry which is outside this curve, so this curve is ending here. Entries which are outside these curves are 1, 2, 3, 4, 5, right? Rest of all the entries are below the curve. So when we know that anything which is outside the confidence level is under the significance level, this is the confidence interval and this is the significance. If this is the confidence, this is the significance. That means data under the curve is insignificant for us or is not useful for us because it's under the confidence level and it is not useful for us. So the data which will be applicable for my equation will be the first lag, the second lag, third lag, fourth lag and fifth lag. So in this equation I'll go up to t minus 5. I'll go up to t minus 5 because rest of the past entries are not having any impact on my variable, or it is insignificant because it is under the confidence interval, right? It is under this area. Anything which is outside this area will have an impact on my output, right? It's basic statistics. You can get most of the videos for these confidence level and significance level on the internet. I've assumed that most of the users who are looking at this video will have this basic idea. That was auto regression. Now we move to the moving average. So moving average is a fairly simple thing that we have been learning all our life, right? If anyone is who is dealing in stocks, they know simple moving average, 20-day moving average, 50-day moving average, exponential average, right? But why is it used? That is more important. So the moving average model accounts for short run autocorrelation. It assumes that the next observation is the mean of every past observation. So in simple terms, if I take this data and I try to plot the mean, this is a constant or a very nominal mean, right? But say suppose I had a data like this, right? I had a data like this and I had to compute the autocorrelation. It will be very difficult, right? But what I can do is I can take the moving average and I can smoothen the curve. This curve is not smooth because it's taking individual value. Say suppose I have value like 1, 4, 10, 12. Example. So now if I plot this, it will be like this, right? 1, 4, 10, 12. But if I take an average, say 1 plus 4 is 5, 5 plus 10 is 15, 15 plus 12 is 27, and I'll divide it by 4. I'll have a very nominal value of 6, right? So this is the average. So this is a simple average. We all know that. Simple average formula, number of instances divided by the total number. Then weighted moving average, WMA, is basically you assign weight to each of the instance or each of the data point and you arrive at a weighted average. An exponential moving average is used in those time series data where the data is exponential. So what we mean by exponential, say suppose you're taking an option price, right? An option time series. Option at the start of the day could be at say 10 rupees. But in the next 5 minutes, it could be 40 rupees, right? So this is not a linear movement. This is an exponential movement. So any time series data which has exponential data, you cannot take simple and weighted moving average. You'll have to take exponential moving average, right? So it depends on the data. If the data is showing that kind of exponential movement, you'll have to take a exponential moving average. This is the simple formula. You can get everything in Excel: exponential moving average, weighted moving average, simple moving average. The point over here is that in auto regression we are regressing the future variable or the variable which has to be predicted against its older values or the lagged values, and we are using the average value, the moving average value, not the actual values. When we combine both, which is auto regression and moving averages, we get an ARIMA model. But we have AR and MA. What is I in this, right? There is an I also. It's called ARIMA, not ARMA, right? So I is for integrated, that the time series is stationary. Going back to the first slide, the very first requirement is the time series has to be stationary. Otherwise, you cannot use an ARIMA model, right? So this is the breakdown of the ARIMA: auto-regressive, moving averages, and integrated. That means the time series is stationary or the time series has been differenced. Like we had taken the difference of the values, right? Over here we had taken the difference of the values, current minus previous. The time series is differenced or is integrated. Now over here, I forgot to tell you one thing. This is the ACF plot, which is auto correlation plot, right? It is showing the correlation of each lagged values. So this is known as the ACF plot. I'll just clear all over this. So this is known as the ACF plot because this will be useful for us in this last slide that I want to cover. So using the ACF plot, we can determine which past values are significant to predict the future, and hence we can take the order of AR. So now using this chart, I know that these are not significant for me. Only these top 5 values or the last 5 lags are important for me. So using the ACF plot, I know what is significant and what is not significant. Okay, this is assumed at 95% confidence level. You can also have 99%. It depends on the data and the output that you're predicting. This order is then implemented in the previous equations to predict the future. What is order over here? Order over here is basically the lag. So I am going up till the fifth lag. So this will be up to the fifth order. So this was more of an ARIMA, right? Uh, Similar to ARIMA is the SARIMA model, but the data includes seasonal data and patterns, right? And hence it is more useful for predicting seasonal businesses such as hotels, travels, etc. So when you have businesses which have seasonality, you cannot use ARIMA because ARIMA does not work with seasonal data. So you have to use the SARIMA model, right? Again, we'll just revise on this one. Auto regression, predicting the future value using the past lagged values. Obviously there will always be some error in your prediction, so this is termed as the error term. This is auto regression, and we don't take the actual values as such. We try to take the moving averages so that we have a smoothened data. When we combine both of them, we get the ARIMA model. But what is I over here? I is the integration, which is the time series used to be stationary. When we run this regression, we get the ACF plot. What is the ACF plot? ACF plot is a correlation of the variables with the output. So we can see lag 1 is highly correlated, lag 2 is highly correlated up to lag 5, but below that it is insignificant. So I can ignore anything which is beyond last 5 periods for my data, right? And then you can use either simple moving average, weighted moving average, exponential moving average, depending on what is the data type. There is some self-study that we have to do. I'm leaving up to you. If you want to understand this model, how does it work, you'll get tons of videos on YouTube how to do this in Python and everything, but I just thought of making you understand the basics of ARIMA. Any model has to be tested for its accuracy, right? How accurate is this model? So there are four values that tell us what is the accuracy of this model, and this is a self-study for you guys. That is mean absolute deviation, that is how much it is deviating from the actual value when we do the variance analysis. Mean absolute percentage error, mean squared error, and root of mean squared error. These are the four variables that gives us how much is the model fit for the regression or the artificial intelligence or machine learning, whatever you call it. It's more from a prediction of the future. So once you understand these concepts in detail, you'll be able to actually understand what is quantitative finance and statistics. Very important is stationarity. Understand how auto regression works. If auto regression is done, there are variables which could be auto correlated, so the lags could be correlated to each other. That means output of October might be dependent on October of September, output of August, XYZ, right? Higher the correlation, more significant. So 1 is more significant, 0.6 is not significant, right? So we have the range of -1 to 1. Moving averages, and then the ARIMA model, and using the ACF plot we can determine, right? So that's it for this session. Thank you.